Let's develop now another rule of differentiation. So the first one is to derive what is the derivative. How can I deduce the derivative of the product of two functions, f and g? Okay. So, let's try to find out. So using the limit, the definition. Okay, so it will be fg at x plus h minus fg at x over h. Okay, so here there is a technique that we will use here. We will work on our term. So if I write in details what I obtain. So I have this difference fx times g of x by definition of the product of two functions. Now I need to use the fact that f is differentiable, so f prime exists and g prime exists, and I know how to find them using the limit. So the idea is to make appear those terms. So fx plus h will need minus fx to get. Okay, so I have gx plus h, so I have the same term here. Now I added, if I develop the second term, okay, it's not given, so I added it, so I need to remove it. So I will add, so just add plus fx times g of x plus h minus the remaining term that we have already, and everything is under h. Now you see here I can separate. I will separate. So I see my derivative for f that is appearing times g of x plus h. Then the other remaining terms here. I see that I can put fx as common factor. Okay, so it will be plus. So let's continue plus. Okay, so I will have fx as common factor times the remaining is x plus h minus g of x over h. So because we have the derivative of f exists and the derivative of g of x, plus this term, the limit exists because a differentiable function, we saw it's a continuous function. So I can say this one will be the limit of this ratio times the limit of g of x plus h. Okay, and so I will write this ratio here plus the limit of fx here as h approaches 0, but it is a constant, it doesn't depend on h, so it's exactly fx, and the limit of the other ratio here. Okay, I will put it here as h approaches 0. Okay, and then I can conclude it's f prime at x times, here we said you use the continuity of g because it is differentiable, then so it will be g of x, g of the limit of x plus h, which is x, plus here fx, and here we will get g prime of x. Okay, so the first rule we obtained here is the following. Let's write it in red. So finally, what we showed here, we established the following, that the derivative, or f times g, the derivative of product of the function. So I derive the first factor, the first function, times g of x, okay, plus fx times the derivative of the second function. With the same idea and tools here, we establish that the derivative of the ratio of two functions f and g is f prime at x, we derive the numerator, times the denominator minus numerator times the derivative of denominator over g of x square. Okay, so these are the two rules we learned today. Okay, here it is. It's not that good. Okay, so let's keep it without these lines here. Okay, so okay, let's now do some examples. Okay, suppose that you are given to derive, find the derivative of x2 times sine x. You see, so instead using the definition with limits, which is hard also to do, to check and exact. Okay, so here now I look at my function as the product of two functions. It's the product, so I can use the product rule. So I will derive the first function of x2, multiply it by sine x, the second, plus I keep so x2, the first function, and derive the second function, which gives me then this is the power function I know to derive it, sine x times sine x plus x2. Now the derivative of sine x, we know that we found it, it's cosine x. Okay, another example with for a ratio, for the derivative of quotient. Okay, so what about deriving? Let's derive now. Okay, another example, the derivative of x plus 1 over x2 plus x minus 2. So I identify the form of my function. I can see it as the ratio of two functions. So I can use this formula. So the formula says derive first the numerator times the denominator, keep it and change it, minus, okay, so numerator, so f, which is x plus 1, then I derive the denominator x2 plus x minus 2 prime over, so the denominator is kept unchanged but taking to the power 2. Now what is the result? Final result, the derivative of x plus 1 is the derivative of the sum of two functions. So the derivative of x is 1, the derivative of 1, which is constant, is 0. So it will be 1 times x2 plus x minus 2 minus x plus 1. The derivative here, so I see it as sum of functions and power functions. So the first one will give me the power x, decrease power 2 by 1 unit, 2 minus 1 will be 1, then plus here the derivative will be 1 and the derivative of constant is 0. Okay, over x2 plus x minus 2 square. So here it is, we can keep it like that without developing, okay, to avoid to do mistakes. Okay, so this is what we learned today, deriving, how to derive, find the derivative of the product of two functions or the derivative of the ratio or the quotient of two functions. Okay, thank you.